All right, so are you ready to dive into some seriously cool science? Today we're going to be talking about Twistronics.
Twistronics.
Yeah, Twistronics. It sounds kind of like science fiction-y, but
It does.
it's a real thing, and it's pretty amazing. Basically, we're talking about like manipulating materials at the atomic level.
Yeah.
Just by like changing the angle between super thin layers.
Like a knob.
It is like a knob. You sent in some research on this, so
Yeah.
let's break it all down.
So what's really wild is how much just this tiny little twist can change
Yeah.
a material's properties.
Yeah.
It's like turning a knob, but instead of being for sound, we're changing
Uh-huh.
things like how well it conducts electricity
Oh, wow.
or even how it interacts with light.
That's incredible. Like, we're basically playing with the building blocks of matter here.
Yeah.
So where did this whole Twistronics thing even begin?
Well, it all started with this big breakthrough back in 2018.
Okay.
Researchers discovered that by stacking 2 layers of graphene.
Gene.
Yeah, you know that wonder material made of a single layer of carbon atoms?
Right.
They twisted them at just the right angle,
Okay.
and they could turn it into a superconductor.
Now, hold on. Superconductor. That's like,
Yeah.
I remember that from like way back in science class.
So,
But remind me again, what is a superconductor?
the superconductor is a material that can conduct electricity with 0 resistance.
So it's like a superhighway for electrons.
Exactly.
Yeah.
And before this,
Okay.
you could only make superconductors work at really low temperatures
Mm-hmm.
or under crazy high pressure.
Oh, wow.
But with this twisted bilayer graphene,
Yeah.
they were able to make it superconduct at a much higher temperature,
Really?
which is like mind-blowing in the world of physics.
I can imagine. So this like magic angle that they found with the twisted graphene,
Mm-hmm.
that's what kind of kicked off this whole field of Twistronics.
Yeah, basically they realized
Okay.
that if we can create a superconductor just by twisting these layers,
Right.
what other properties could we control?
Hmm.
So it's just kind of like opened the floodgates to research into
Yeah.
other materials and
Makes sense.
different twist angles.
Yeah. It's like discovering a secret code or something that
Yeah.
unlocks all these crazy possibilities. So, okay, we've got this incredible tool, Twistronics. It could like revolutionize everything from electronics to quantum computing.
Yeah.
But there's got to be some kind of catch, right?
Well, you're right. The biggest problem was actually like making these twisted structures.
Oh, really?
Each device had to be made by hand, like atom by atom.
Wow.
Super time-consuming and difficult.
Yeah.
And even then, no 2 devices were exactly the same.
Ah, so it's like trying to experiment with snowflakes.
Yeah.
Each one is unique, and I can see how that would be a nightmare for research.
Yeah, you can't compare your results
Right?
or really know if your conclusions are right
Exactly.
if every experiment is using a different device.
Yeah.
And that's where the research you sent in comes in. Scientists have developed a new device called
What is it?
MEGA2D.
MEGA2D. All right, that definitely sounds like something out of a sci-fi movie.
Right.
So tell me, this thing can actually twist these materials at any angle we want.
It can.
Yeah.
Imagine a tiny machine about the size of your fingernail
Okay.
that can like manipulate materials at the atomic level.
Wow.
That's
Yeah.
MEGA2D.
So we've gone from like meticulously crafting these devices by hand
Yeah.
to having a machine that can do it with just like
Pretty much.
the push of a button.
You got it. And to really understand how big of a deal this is,
Yeah.
imagine trying to build like a Lego masterpiece.
Okay.
One brick at a time with your hands
Uh-huh.
versus having a robotic arm
Right.
that could place each brick perfectly.
Wow.
That's the kind of control we're talking about here.
So this MEGA2D is like the ultimate Lego set for material scientists.
It is.
This must open up a ton of possibilities for Twistronics research.
Yeah, it takes this field from like painstakingly slow to warp speed.
Now we're talking. But before we get into all that,
Yeah.
I'm curious about MEGA2D itself.
Okay.
How does it even work? Did they just stumble upon this by accident?
Well, it definitely wasn't easy.
I bet.
It took the researchers a whole year
Yeah.
to fine-tune the design
Uh-huh.
and figure out how to control the interfaces of these super thin materials.
So a lot of trial and error,
Yeah.
late nights in the lab.
You could say that.
I can imagine.
And they also had help from the people at Harvard's Center for Nanoscale Systems.
Oh, wow.
Because to make a device this complex
Right.
with this level of precision, you need some serious nanofabrication skills.
So it was a real team effort then, like
Ah.
combining the science with some serious engineering know-how.
Yeah.
And the result is this tool that could revolutionize how we study and manipulate matter
Pretty much.
at the most fundamental level.
Exactly. And that's where it gets really exciting.
Okay.
Now that we have this tool, what can we do with it?
I'm on the edge of my seat. What kind of puzzles are scientists hoping to solve with this new knob that they can control?
Yeah. Remember how we were talking about twisted bilayer graphene?
Yeah.
Acting like a superconductor?
Yeah, that just blew my mind. It's like we're rewriting the rules of physics.
I know, right? But here's the thing. We still don't fully get why it works.
Oh, really?
Yeah. MEGA2D lets us really precisely control the twist angle.
Okay.
And study how that changes the material's properties. It's like having a microscope that lets us look into the quantum world.
Wow.
And actually see how those electrons are behaving.
So we can finally go beyond just seeing it happen to actually understanding why.
Exactly.
That's huge.
Yeah, it's like we've got this key now.
Okay.
To unlock the secrets of superconductivity. And that could have big implications for all kinds of tech.
Okay, so paint me a picture here. What are we talking about?
Imagine a world with power grids that don't lose any energy.
No more wasted energy.
Nope.
Wow.
Think about super fast electronics that don't use much power.
Okay.
We could be talking about a whole tech revolution.
Wow, that would change everything.
Yeah.
And to think this all started with just messing with the angles of atoms.
I know.
But you mentioned other materials, too.
Right.
What else is on the Twistronics hit list?
Well, they're already doing experiments with twisting other 2D materials, like hexagonal boron nitride.
Wait, hexagonal boron nitride, didn't the research you sent?
We mentioned that.
Yeah. It's like graphene's cousin.
Okay.
And they used MEGA2D to twist layers of hexagonal boron nitride. And they found evidence of these crazy things called...
What were they called?
Quasi-particles.
Quasi-particles. Okay, that sounds like something out of Star Trek.
It does kind of.
Break it down some.
Okay, so imagine a ripple moving on a pond.
Okay.
That ripple acts like a particle, right?
Yeah.
Even though it's just a disturbance in the water.
Right. So a quasi-particle is kind of like that.
Okay.
It's a bunch of particles acting together, but it behaves like a single particle.
Okay, I think I'm getting it.
Yeah.
So what's so special about these quasi-particles in the hexagonal boron nitride?
Well, the fact that they have topological properties.
Topological properties?
Yeah.
Remind me, what does that mean?
It means they're super robust.
Okay.
They don't change even if you stretch or bend the material.
So they're like tiny little indestructible information carriers or something?
Yeah, that's a good way to put it.
Yeah.
And that makes them really promising for quantum computing and information processing. Because you could have a quantum computer that isn't as sensitive to errors.
Now we're talking. So we've got superconductors, ultra-efficient electronics, and maybe even more stable quantum computers.
Exactly.
Is there anything Twistronics can't do?
Well, it's still early days, but
Ew.
the potential seems pretty huge.
Yeah.
And remember, we've been mostly talking about electronics and computing.
Right.
But Twistronics could revolutionize optics, too.
Optics, so like lasers and fiber optics and all that.
Exactly. Remember those quasi-particles we talked about?
Topological ones.
Yeah. They could maybe be used to make super efficient light sources.
Okay.
For optical communication.
So we're talking about faster internet, better telecommunications.
Yeah.
Maybe even new ways to send data with light.
Yeah, you got it.
Yeah.
And traditional fiber optics.
Yeah.
Use light pulses that lose energy as they travel.
Right.
But with these topological quasi-particles, we could maybe create light that doesn't lose energy.
Oh, wow.
Leading to much more efficient long-distance communication.
This is incredible. We've gone from playing with atoms to potentially changing global communication.
I know, it's pretty amazing.
It's mind-boggling.
Yeah.
But I gotta ask, is there anything beyond these specific applications? Is there a bigger picture here?
Absolutely. What's really revolutionary about Twistronics is that it's not just about finding new materials.
Okay.
It's about changing how we design materials. It's about understanding how a material structure and its function are related.
Okay, break that down for me.
All right, so we've been talking about how the twist angle, which is a part of the structure, can drastically change the material's function.
Like making it a superconductor.
Exactly, or creating these quasi-particles.
Right.
But what if we could do this with other parts of the structure?
Okay.
What if we could control the space between atoms or arrange the molecules in specific ways, all with that precision that MEGA2D gives us?
So we're talking about becoming architects of matter, then building materials from scratch with exactly the properties that we want.
Exactly. And that's why this research is so groundbreaking. It's not just about finding the next great material.
Right.
It's about being able to design any material we can imagine.
Whoa. So we could have building materials that are lighter and stronger, more efficient solar panels, maybe even fabrics that can change what they do on demand.
It's like something out of a sci-fi movie.
It really is. But what if we take it even further?
Okay.
If we can control these structural features so precisely,
Yeah.
are there properties we could create that we haven't even thought of yet?
That's the really exciting part.
I bet.
We're just getting started.
Yeah.
Like, think about it. We've only just looked at twisting 2 layers.
Right.
What happens when we stack 3 or 4 or even more layers?
Oh, wow.
And start playing with all those angles?
Okay, now my head is spinning.
It's a lot to take in.
It is. It seems like every time we answer one question, a bunch of new ones pop up.
It's true.
This is what I love about the deep dive.
What's that?
We start with something that seems simple, like twisting layers of atoms. And suddenly we're exploring a whole universe of possibilities.
That's science for you.
It is. Speaking of which, we've covered a lot of ground today.
We have.
We've looked at how Twistronics started, what MEGA2D can do, and all the amazing things it could lead to.
Yeah.
But before we wrap up this deep dive, I want to bring it back to our listener and ask, how could all this Twistronics stuff actually, affect our lives for the future?
That's the big question, isn't it?
Yeah.
It's easy to get caught up in the sci-fi aspect of it all.
You're right.
But really, this stuff could change everything.
So it's not just about cool gadgets and, super fast internet.
It's bigger than that.
We're talking about a fundamental shift in how we live and how we interact with the world around us.
Exactly. Think about something like your smartphone.
Okay.
Right now, they're limited by battery life, how fast they are.
Right.
Even the materials they're made from. But imagine a phone with a battery that lasts for weeks.
Okay.
A processor that's way faster.
Wow.
All while being lighter and tougher.
Yeah.
Because it's made with these super advanced materials designed at the atomic level.
That's a future I can definitely get behind. But what about stuff beyond our phones and computers?
Right.
How could this affect things like healthcare or energy?
Imagine being able to make materials that work perfectly with the human body.
Okay.
We could create artificial tissues.
Wow.
Organs.
Really?
Even prosthetics that work just like the real thing.
That's incredible.
And for energy,
yeah.
Think about solar panels that are way better at collecting sunlight.
Uh-huh.
Or batteries that can store power for much longer.
It sounds like we're talking about solving some of the biggest problems we face.
Exactly.
But is this all just speculation or
no?
Or are we actually getting close to seeing some of this stuff happen?
This is real science.
Okay.
That's happening right now. Like that discovery with the twisted bilayer graphene and the superconductivity.
Yeah.
That was just the beginning. Now with tools like MEGA2D, things are moving super fast.
So it's not a matter of if, but when we start seeing these Twistronics technologies become part of our lives.
It might be a few years.
Yeah.
It might be 10.
Okay.
But it's definitely coming.
That's so exciting. Well, I think we've given everyone listening a lot to think about today.
I think so.
It's amazing to think that just by tweaking the angle between atoms,
I know,
that we could have this huge impact on the world.
It really shows you the power of basic research.
Yeah.
Sometimes the most unexpected things lead to the biggest changes.
Absolutely. It reminds us that there's still so much we don't know about the universe and how it all works. Who knows what other incredible discoveries are out there just waiting to be made?
That's right.
Maybe by someone listening right now.
I love that idea.
Me too. I think that's a perfect note to end on.
I agree.
It's a world full of possibilities.
Yeah.
Just waiting for us to find them.
That's right.
Well, a huge thank you to our expert for breaking all this down for us today.
You're welcome.
And to everyone listening, thanks for joining us for this deep dive into the world of Twistronics.
Thanks for having me.
We hope you learned some cool new stuff.
Yeah.
Had your mind twisted just a little bit.
A little bit.
And maybe even got a glimpse of the amazing future that Twistronics might bring.
Who knows what's next?
Until next time, keep exploring.